Hello. Today we're going to consider a very special situation. I mentioned this a few videos ago, and the situation is that I'm going to use the methods of finding relative extrema, max min, to get an absolute extrema, okay, max and min. So let's kind of break down what we have and see what we need to do. So remember, we kind of have looked at this over the last few videos to find absolute extrema, absolute max and min. We used EVT, extreme value theorem. And for that, I needed a continuous function. F of x was continuous on the closed interval AB. And with that, we knew that there exists absolute max and absolute min. There exists some C and D where f of C and D in the interval from closed interval AB, where f of C is the absolute max and f of D is the absolute min. Okay, this is what we had in terms of absolute extrema. We needed this very special situation to guarantee that an absolute max or absolute min and absolute min occurred. As I mentioned, a long time ago, generally speaking, it's hard to determine if you are going to get an absolute max and absolute min. This one situation guarantees it. And then we kind of jump to relative max min. And to find relative max min, relative extrema, let's put it that way, we used either the first derivative test or the second derivative test. Okay, and so depending on the circumstances, one was usually easier than the other, but we have the first and second derivative tests, and that actually, helps us. It's in some respects easier to find relative extrema than absolute extrema. Again, there's, you have to take the derivative and set it equal to 0, find your critical values, etc., that we've talked about recently. But, this is our methods, are the methods that we use to find relative extrema. Now, there is one situation where we can use the methods of relative extrema to get an absolute extrema. And that situation is as follows. If my function f of x is continuous over the entire domain, and the domain is a single interval, doesn't matter if it's closed, open, or whatever. And my function has one relative extrema in that interval. Exactly one. Then that relative extrema is an absolute extrema. Okay, so let's see, I'm not going to prove this, but we'll kind of see why it makes sense, and I'm going to erase this from our dealings with the past. What this basically says is if I have a continuous function over the entire domain, which is a single interval. So for example, simplest case is I have something like a parabola. The graph is a quadratic function. Now this does not satisfy the conditions for EVT, but we know from college algebra that this has a single either absolute max or an absolute min, depending on the direction that the parabola opens. But what we have now is, in this particular case, notice function is continuous over the entire interval. The interval in this case, the domain, is single interval from negative infinity to positive infinity, and in this particular case, it has exactly one relative min. Well, actually, exactly one relative extrema. In this case, it is a relative min, and so based on what I said over there, that means it's an absolute min. Okay, so, or if I have, for example, a graph that does something like this. Let's suppose it's open on this end and goes like that. Again, the interval in this case is from 0 to infinity. My domain, this is continuous everywhere. It has exactly one relative extrema, so this is an absolute extrema. In this case, an absolute max. Okay? So with this process, assuming I have these conditions satisfied, we can use the methods of relative max-min, which are generally easier. Take the derivative, assuming my function isn't really super ugly. We can take the derivative, set it equals 0, and find the critical values, etc. And then, assuming I only get one relative extrema, and I do that, then it's actually an absolute. And we are about to use this. We will use this result to find optimal values. For functions called optimization. And generally, we are looking for the optimal values are either the absolute max or the absolute min. We're looking for one of these. We want either the absolute max or the absolute min. And most of the time, the intervals that we're dealing with will not be closed intervals where we include both endpoints. Hence, EVT won't apply, and so the methods that we did previously for absolute don't work, but this condition will generally hold. And so therefore, it will allow us to find the optimal value in this particular situations that we're dealing with.